Good day, I'm Maile Madziba. Welcome back to our channel. We continue with our CIR 113 module and we're continuing with our question 3 of semester 1 of 2018. Today we're looking at question 3.1. It says, you are given a 2.43 pound mole per feet cubed solution of H2SO4 in water. Calculate the concentration of the solution expressed as A, molarity, and B, normality. So we'll start with our A, calculating the concentration as, or expressing the concentration as molarity. Now we know the equation of molarity. Molarity is equals to the number of moles of solute all over the liter of the solution. Now in this context, the solute is the H2SO4 and the solution is the combination of H2SO4 and water, because they say that the H2SO4 is in water. Which then means that if we can get the number of moles of H2SO4 in the solution and we can get the volume of the solution, then we can be able to find the molarity. Now another important thing that we need to notice, we haven't really been given, many values. We have a value here, it's 2.43 pound mole per feet cubed. Now this is actually pound mole H2SO4 per feet cubed of the solution. So basically, to a certain extent, this helps us to find our molarity. So the best way to actually find the molarity is to convert all these into SI units, or we can make it more easier and say we can actually convert, because this is moles and this is volume, we can actually convert this into gram moles per liter, and that we can then take it from there. With that said, we can just say 2.43 pound mole per feet cubed. So we're gonna be converting from here into gram moles per liter. So we can just start with the feet cubed and convert it to meter cubed. So we know that 1 feet is equals to 0.3048 meters, and we can cube that so that we can actually have our feet cubed here and meters cubed there. And I think from our high school background of mathematics, we know that cubing this doesn't really affect the answer, because this is 1. So even if when you cube it, it's still 1. So then next, we can convert our pound mole into pound mass. So we know the molar mass of H2SO4 is 98. So we can say 98 pound mass all over 1 pound mole. So, and then next we can convert the pound mass to kilograms. So we say multiply by 0.4536 kilograms all over 1 pound mass. And then next we can convert the kilograms into kilomole. And then we know that the molar mass of H2SO4 is 98. We can use that again. So we can just say 1 kilomole all over 98 kilograms. This is actually basically the inverse of the molar mass of H2SO4, because we know it is actually 98 kilograms per kilomole, or 98 grams per gram mole. So now we have converted from, okay, let me just cancel, just so that we have consistency. Let me cancel what we know we have cancelled. So the feet is gone, the pound mole is also gone, the meter cubed is also, no, sorry, the meter cubed is not gone, not yet. We still have the meter cubed, and the pound mass is gone, and the kilograms is gone. Right, yeah. So now we have converted this to kilomole per meter cubed, right? The cubed here still stands, sorry about that. So we have our kilomole per meter cubed. So now how do we need to convert from kilomole into gram mole? So we know that 1 kilomole is equals to 1000 gram moles. So you can say 1000 gram mole all over 1 kilomole. So when we have 1000 gram mole per, let me write it properly, all over 1 kilomole, then we have converted the kilomole into gram mole. Now we are left with the meter cubed. We need to convert the meter cubed into liters. We can just say, we know 1000 liters is equals to 1 meter cubed. So we can just say 1 meter cubed all over 1000 liters. So when you use your calculator, that gives you 38.9255 gram moles per liter. So we know from this equation that it's actually gram moles H2SO4 per liter of solution. So we can just say, therefore, our molarity is equals to 38.9255 gram mole H2SO4 all over or per liter of solution. So this then becomes our molarity. So we have actually answered our question A. So then we go to our question B. Question B says calculate the normality. So the normality, the equation for calculating the normality, especially when we have the molarity, it's very easy. So it's normality is equals to the molarity multiplied by the n factor. Now, the molarity is what we calculated here, and the n factor is actually, the number of hydrogens in the acid. Normality deals with acids and also bases. So it actually it's basically multiplying the molarity with the number of hydrogens in that acid or in that base. In this case, we have our H2SO4, which has 2 hydrogens. So that would mean our normality is simply 38.9255 gram mole per liter multiplied by 2, right? And if you use your calculator, that then gives you 77.851 gram mole per liter solution. So that is basically our normality, and this actually wraps up our question 3.1 of our 2018 semester test 1 of our CIR 113. So thank you guys for your time, and I hope we meet again in our next video.